Alright, in this video here we're going to be talking about reference angles. So reference angles are things we can use to evaluate trigonometric functions of angles using the values that we know from the unit circle. Right? So basically a reference angle is going to be one of the angles we know from the unit circle from the first quadrant or that we can use with our trig hand. If you haven't seen the videos I did on trig hand, I would advise you to check those out. But it's a way to take any angle in any quadrant and kind of work with it in terms of the angles that we know from the first quadrant, where we know what the terminal points are on the unit circle, and we know what the values of the sine, cosine, tangent functions are, and so on. All right, so the definition of a reference angle. So theta is our angle in standard position. Right? Remember, standard position means the vertex of the angle is at the origin, and the initial side is on the positive x-axis. Right? So theta is in standard position. The reference angle, which we call theta bar, which is that same symbol theta, but with that bar, that little line on top of it, so we call that theta bar, is our reference angle. It's the acute angle formed by the terminal side of theta and the x-axis. All right, so first of all, some terminology from geometry, which hopefully you remember. An acute angle is an angle that's less than 90 degrees. Okay, so that's acute angle. That's an acute angle. And so the terminal side of our angle theta, that's where the angle ends, right? Terminal side means the ending side, right? So our first example here, if our angle is in the first quadrant, right? So my initial side would be the positive x-axis. My terminal side is pointing up through the first quadrant there. Well, in that case, my angle theta is equal to theta bar, right? The angle is its own reference angle because the acute angle, or the smallest angle that will get me to the x-axis, is the one that I already had to get to my terminal side, right? So in the first quadrant, the angle that you have is the reference angle, all right? If my terminal side of my angle is in the second quadrant, right? So here I'm starting on the positive x-axis as my initial side. I'm rotating this way, so this one's going to be a negative angle, and it ends up with the terminal side in the second quadrant. So that whole thing there is my angle theta. Now my angle theta bar, my reference angle, is from this terminal side down to the x-axis, right? That acute angle, that smaller angle there, remember acute is less than 90 degrees, right? So that smaller angle that takes me back to the x-axis, that's my reference angle, all right? So that's my theta bar. Right? If my angle is in the third quadrant, right? Once again here we have a negative angle, it's going this way, and our terminal side is in the third quadrant, right? So that's my angle theta right there. The reference angle theta bar is the angle that takes me from that terminal side up to the x-axis, right? That's the acute angle. It's less than 90 degrees, all right? And then the last one here, if my terminal side is in the fourth quadrant, right? So I'm starting on the positive x-axis. I'm rotating all the way around to the fourth quadrant. That's my angle theta. The angle theta bar is going to be that acute angle between my terminal side and the positive x-axis, right? So when you're in the first quadrant or the fourth quadrant, your reference angle is taking you to the positive x-axis. When you're in the second quadrant or the third quadrant, like these two, your reference angle is taking you to the negative x-axis on the left side, right? It's always the smallest angle from your terminal side to get you to the x-axis, right? So in the second and third quadrant, it's taking you to the negative x-axis. First and fourth quadrant takes you to the positive x-axis. All right, so that's what we mean by reference angle. And again, we can use the reference angle if the reference angle is one of the angles that we know from the first quadrant, and we know from our trig hand and our unit circle work, then we can use that reference angle to help us evaluate the trig functions for these other angles that end up in different quadrants besides just the first quadrant. All right, so that's the reference angle, and this is very closely related to something I talked about on a previous video when I was talking about the unit circle and the trigonometric functions in terms of the unit circle. And in that case, we weren't talking about angles, but we were talking about t-values, which was the distance we were traveling around the unit circle one way or the other, along the circumference of the circle, and we had reference numbers, right? So the reference number is kind of like the reference angle here. So if you recall the stuff I talked about with reference numbers, it was the shortest distance from my t-value to the x-axis, right? So, but it was going along the circumference of the unit circle. Here, the reference angle is just that acute angle that takes me back to the x-axis. But whether it's a reference number or now the reference angle, it's still dealing with the x-axis, right? So we're never trying to get ourselves to the y-axis when we're looking for reference angles or reference numbers. We're always doing it in terms of the x-axis. All right, so that's our definition of reference angles. What I'm going to do here is pause the recording and put up an example where we do an example problem finding reference angles for angles that are in radians and also in degrees, right? So we'll see how it works for both of the measurements of angles. All right, so put up here a couple examples. The first one, we have theta equals 5 pi over 3. The next one, theta equals 870 degrees, and we want to find the reference angles for both of these. All right, so first, for the one that's in radians. Now, if you watch the videos that I did on reference numbers for t values that were measured in radians, the same little shortcut applies to angles that are measured in radians. When I see my theta is 5 pi over 3, right, that pi over 3 there tells me that my reference angle, theta bar, is just going to be pi over 3. Right? If it's one of the pi numbers over the denominator, your reference angle is going to be, forget that number in the numerator, it's just going to be pi over that same denominator. Right, so that's a shortcut when you're doing these reference angles for radian measures. But just to show you why that works, just to kind of explain that, just so you take, I wouldn't take anybody's word for it, like, oh, it's just this, it's real simple, just go ahead and do that, unless I knew that that was true and it was going to work. So let me explain to you why this shortcut works and why it's going to be true every time. All right, so let me draw myself the angle 5 pi over 3. So the question is, where is that angle 5 pi over 3? Well, remember, when we're dealing with radian measures, the positive x-axis is 0 radians, the negative x-axis would be pi radians, a full revolution back to the positive x-axis would be 2 pi radians. So the question then is, well, where does 5 pi over 3 fit? Is it between 0 and pi? Is it between pi and 2 pi? Or is it even bigger than 2 pi and it's like more than one full lap around the circle? So that's the first thing to decide. Well, 5 pi over 3, you have 2 pi. If I write 2 pi in terms of a denominator of 3, right? If I do 2 pi over 1 and multiply by 3 over 3, I get 6 pi over 3. Right? So 2 pi is the same as 6 pi over 3. Right? So 5 pi over 3 is not quite there. It's a little bit less than 6 pi over 3. Right? So 5 pi over 3 is going to be in our fourth quadrant. Right? So an angle of 5 pi over 3 is going over to here. Now, if you're not sure that it's the fourth quadrant, you're like, well, it's less than 2 pi, yeah, but what if it's in the third quadrant? It could be over there. That's also less than 2 pi. Well, think about it like this. Here's pi, right? That would be, 1 pi would be 3 pi over 3, right? Because 3 over 3 equals 1, just like here, 6 over 3 equals 2 to give us 2 pi, right? So 3 pi over 3, right? So if I'm counting by pi over 3, or by 1/3 of pi, right? I start at 0. Up here is going to be 1 pi over 3. Over here is going to be 2 pi over 3, right? That's 2/3 of pi. Here's 1 full pi, right? That's 3 pi over 3. Down here is going to be 4 pi over 3. And then over here is 5 pi over 3. And then the full circle, or the full lap around, is going to be 6 pi over 3, which is 2 pi. Right? So that should hopefully convince you that 5 pi over 3 does belong in the fourth quadrant, not in the third quadrant. All right? The one over here would be 4 pi over 3. And I did a video a while back on the unit circle and the radian measures of the unit circle, where I gave you some hints and some patterns of how to figure out what the values are for each quadrant. Like each quadrant has a pi over 3 number. The first quadrant is 1. The numerator is 1 pi, I should say. The second quadrant, the numerator is 1 less than the denominator, so it's 2/3. The third quadrant, the numerator is 1 more than the denominator, so it's 4/3. And then the fourth quadrant, the numerator is 1 less than 2 times the denominator. Right? So 3 times 2 is 6. 1 less than that is 5. So it's 5 pi over 3. All right, so if you remember those shortcuts, you don't have to do all the stuff I did here. You just remember, 5 pi over 3, yeah, that's 1 less than 6 pi over 3, so that has to be in the fourth quadrant. Right? So, and if you haven't seen that video that I did where I talked about all those little tips and tricks to remember the numbers on the unit circle, you might want to check that out, because there's a lot of little patterns that are in there that can help you locate where 5 pi over 3 is a lot more quickly than how I just explained it here. Again, I'm trying to give you explanations here instead of just shortcuts, which is why I gave that longer explanation. Right, so I know 5 pi over 3 is going to be in that fourth quadrant, and so my reference angle is going to be the acute angle that takes me from my terminal side, which is this one in the fourth quadrant, to the x-axis. Right, so this right here, that's going to be my theta bar. Right, that angle between the terminal side at 5 pi over 3 up to the x-axis, which would be 2 pi. Right, so to find that angle, I have to do 2 pi minus 5 pi over 3. Right, 2 pi is a full revolution I'm subtracting the 5 pi over 3 that I went around to here. That's going to give me the angle in between those two, right? And 2 pi, as we just saw, is 6 pi over 3. Right, so really what I'm doing is 6 pi over 3 minus 5 pi over 3, which equals 1 pi over 3, which is what I told you before. That's what your reference angle is always going to be when you're dealing with these radian measures. Right? If it had been 4 pi over 3, well, between 4 pi over 3 and pi going this way, well, 4 pi over 3 minus 3 pi over 3 is going to be 1 pi over 3. Right? If my original angle was 2 pi over 3, well, 3 pi over 3 minus 2 pi over 3 to get this angle here is 1 pi over 3. Right? So no matter which quadrant I'm in, no matter what my numerator is for my pi over 3 number, the reference angle is always just going to be pi over 3. Right? And it's not just for pi over 3. That works for pi over 4 numbers, for pi over 6 numbers. It doesn't matter. Right? So whatever this numerator is, just kind of ignore that number and just take the pi over the denominator. That's always your reference angle when you're dealing with radian measures of angles. All right, so just to kind of prove to you why that works, or at least for this example to show you why that works, hopefully that's enough for you to be convinced that you can just take that shortcut. If not, you do what we did here, and each time you'll see that it comes out to the pi over the denominator. All right, so that's my reference angle, again, between my terminal side and the x-axis. That angle right there is going to be pi over 3. All right, next one. Theta equals 870 degrees. All right, so I need to find the reference angle for 870 degrees. All right, so first I have to figure out where in the world is 870 degrees, right? So, well, I know 870 is more than 360. Remember, 360 degrees is a full revolution. So I'm doing one full revolution around the circle. That's 360 degrees, right? I'm going to kind of keep a running tab over here so I don't lose myself in my calculations, right? So if I do another full lap around the circle, that's another 360. That's going to take me to 720 degrees, which is still less than 870. So I'm doing 2 full loops around, 2 full rotations or 2 full revolutions. And then 720, another 360 is going to take me above 870. So now what I'm going to do is 870 degrees minus 720 degrees, and that's going to give me 150 degrees. Right, so I go 2 full laps around the circle, and now 150 degrees more. Right, well, I know that over here is 0 degrees, all the way around is 360. I know that the positive y-axis would be a 90-degree angle. I know that all the way to the negative x-axis would be 180 degrees. And I know that down here would be 270 degrees. All right. So if I'm going another 150 degrees, that means I'm going around here, but I'm not going as far as 180. Right. I'm stopping before I get to 180. Right. So there's my angle of 870 degrees. Right. 2 full laps around the circle, or two full rotations, and then another 150 degrees beyond that, which takes me over into the second quadrant. All right, so that is what my angle looks like for 870 degrees, 2 full revolutions and then another 150 degrees. Now, if I want to find my reference angle here, I don't have to use the 870. I can use this 150 degrees to get my reference angle. Right? If you haven't seen the video that I did on coterminal angles, the angles 870 degrees and 150 degrees are coterminal with each other, right? If I did a 150 degree angle, it would be starting at this positive x-axis and just rotating over here, and it's going to have the same terminal side as this 870 degree angle that was 2 full revolutions and then another 150. Since they're coterminal, I can just use that 150 degrees to get my reference angle. And my reference angle is going to be the angle between my terminal side and the x-axis. Right, so it's the angle between 150 degrees and 180 degrees, and to figure that out is not too hard. I do 150 minus 80, and I get 30 degrees. Right, so for 870 degrees, my theta bar, my reference angle, is going to be 30 degrees. Right, my terminal side is 30 degrees above the x-axis up here in the second quadrant, right, because it's coterminal with 150 degrees, and 150 is 30 less than 180, which is the x-axis, right? And it's the same thing we did here, right? Although I'm doing on the opposite side. Here was the positive x-axis, so I did 2 pi minus my angle 5 pi over 3. Here, since it's on the left side, I'm doing 180 minus my angle, so 180 minus 150 to get my my reference angle. All right, and then again, once we get reference angles, the pi over 3 or the 30 degrees, then I can go, well, 30 degrees is this finger here, so now I can use what I know about my trig hand and the unit circle to figure out the sine, cosine, tangent, or whatever of 30 degrees. Same deal for pi over 3. I can use my trig hand to figure out what I need to there. That's why we do reference angles, so we can use what we know about the first quadrant.